Okay, yes, let's start this unit of Fourier series. The unit is a very short unit, so actually we are going to see just the basic. We are not going to cover much of the Fourier series. But before starting the problems and the concepts, we are going to start with some background information. Okay, some background information. Information that you will need to start doing the Fourier series. Okay, first of all, first concept, even and odd functions. You may remember this as funciones pares or funciones impares, right? They're just even or odd function. Now, what is the property of an even function? Well, an even function, the property is that it's a plot that has something like this. So what happens on the positive happens the same in the negative. Same in positive and in the negative side. Alright? So that is an even function. So it doesn't matter if it is positive or negative. According to the y-axis, the right side and the left side, they happen to be just the same. Okay, they have the same behavior. Now this is graphically, but the definition is like this. An even function is something that in the minus x is equal to the function even in the positive. Now, here's the same concept. So what means here is that the negative is going to be equal to the positive. Alright? Okay, now what is an odd function? Odd function, that is not clear. An odd function is something like this. So very similar, but here what happens here is that this is the positive function. Now on the negative is going to be the same, but below the x-axis. So this is in the negative part. So as you can see here, the even function is just exactly the same, but the odd function is something that is in the positive. The negative part behaves the same as the positive, but below. So that is the odd function. Now, so what happens here is the same as in the positive, but low in the negative side, but in the negative side. Maybe that's not is not a good definition, but this is the concept. Now, what happens? The property of an even and odd function mathematically is that the negative side is equal to the minus the positive side. Odd function. Okay. Now, here you can see here this definition and this definition is here in the negative side of x. In terms of on the y, they are the same. On the negative side of x, in terms of the y, it is the same, but in the negative of the y. Okay, the negative side of y. Okay, so that is a very important thing in the even and odd function. Now, according to the integrals, that's a very important concept. So this is the behavior now. In the integrals, imagine that you have a minus L and here plus L, the same length. Okay, now if you try to make the integral of minus L to L of an even function, that is equal to a differential of x here. Now, what happens here is that you can reduce the integral that you are trying to calculate is all this. All this. Now, because it is an even function, so what happens on the positive is the same as the negative. So there's no need to calculate from minus L to L. What you can do is 2 times the integral from 0 to L of the even function, differential of x. Alright? So you just calculate from 0 to L and then you multiply times 2 because it is actually the same area. Okay, now what happens on the, this is the interesting thing. What happens if you happen to have minus L here plus L? Now you are trying to calculate the integral from here to here. Okay, now you may assume what is the result. The integral will be 0 because this is negative area and this is positive area. So the addition of 2, they cancel together each other, and the integral from minus L to L of an odd function of x, differential of x, is always 0 because this cancels this. All right. Okay. You may know some of the you may already know some of the functions that are even and odd. For example, let me give you one example that we are going to need. Let's clear this. Remember, this is just background information before jumping to the Fourier series. Okay, now if you remember this plot, what is this plot? This is actually the sine of x. Now what is this? The sine of x is even or it is odd function. Es par or es impar. Now I can see here from here to here, from minus pi to pi, that this is negative and this is positive, and this behaves the same as the negative here, but it is an odd function. Odd function. So imagine what will be the integral from minus pi to pi of the sine of x differential of x. Well, that is actually equal to 0. Okay. Now this is true even if you have any number like here, sine of 3x or sine of 5x or whatever. The only difference is that it's going to be have more frequency, or it's going to have low frequency. But the behavior is the same. It's just you just make it large or you compress the function, but it is the same. It's the same behavior because the negative and the positive will cancel anyway. Now, so in this case, the sine of an x is equal to 0 from minus pi to pi. Now you have to have this, the same distance from here to here. Okay. Okay. Now what about the cosine? Now if you remember the plot of the cosine is something like this. Now this is minus pi and this is pi. All right. Okay. Now tell me. What is the area under the curve? Okay. Now, by the way, first of all, it is an odd or even function. Well, the cosine of x is an even function. Why is an even function? Because the positive behaves the same as the negative. It's just a reflection. All right. Okay. It's an even function, but what I'm interested here is the integral from minus pi to pi of the cosine of x differential of x. Now, because it is an even function, we can calculate from 2 times the integral from 0 to pi of cosine of x differential of x. But even from 0 to pi, you have here a positive integral, positive area, and here you have a negative area. So this cancels with this. Okay, so still is equal to 0. That doesn't mean the cosine is an odd function. It's still an even function, it's just that this cancels here. And you can see from here this is positive and negative, and it's going to also cancel if we keep from minus pi to pi. Okay, so bring two concepts. First, keep this formula. You are going to need it later, and also keep this formula is equal to 0. Actually, this is also an x, same concept. Cosine of nx differential x. Now, this is also equal to 0. Okay, now, what happens if we multiply functions even and odd? What will be the behavior? Okay, we are still in the concept of even and odd functions. Now, if you remember this concept, I'm sure you do, because positive times positive is equal to positive, right? Positive times negative is equal to negative, or negative times positive is equal to negative, but negative times negative is equal to positive. Okay, now this is the law of the signs, la ley de los signos. Now, it's a very similar case for even and odd functions. Okay, now what happens here is that an even function of x times another function that is also even, it's also, the result of this multiplication is going to be even. Alright, now, a function, an odd function times of x, times an even function of x, the result of this multiplication is going to make an odd function. Alright, so very similar to the law of the signs. Odd times even is equal to odd, or even times odd is going to be odd. Alright, now this is the interesting part, because we kind of expect that if even times even is going to produce an even function, right? But this is the funny thing here. An odd function of x times another odd function of x, the result is going to be even function. Okay, so very similar to the law of signs. Odd times odd is produce an even function. All right, so very important, very interesting thing. And odd times even makes odd. Okay, so let me tell you. Let's do this exercise. What will be the integral from minus pi, minus pi to pi of the cosine of nx times the sine of nx, or even mx, they don't have to be the same. Okay, differentiate x. Alright, now, because the cosine is an even function and the sine is an odd function, the result of this is an odd function. Now, the integral of an odd function from minus pi to pi is going to be equal to 0. So this is just another formula that we are going to need. Alright? Okay, I'm going to stop here on this video. Next video we are going to cover more formulas that we are going to need. Alright? See you in the next video.